I'm standing outside a truck depot in regional New South Wales where diesel trucks drive in one end and electric trucks drive out the other. And when those trucks run out of charge, they don't plug in. They swap the whole battery in less time than it takes to fill a diesel tank. I'm Rosie Barnes, an engineer with a PhD and 20 years experience developing clean energy technologies. Welcome to Engineering with Rosie. The last video that I did on electric trucks looked at the challenges that they'll face as they scale. Things like getting sufficient power to the places that trucks want to charge at the times that they want to charge. It was very much a problems, a challenges focused video, not so much a solutions focused one in terms of solutions that are available today. A whole lot of viewers pushed back in the comments saying that there are plenty of solutions available today, and battery swapping was one of those solutions that kept on coming up. He pointed out that swap stations could sidestep the whole grid connection problem by charging batteries slowly overnight, that swap stations fit naturally into the depot model fleet operators already use, and that some of you had already seen it working. Janus Electric came up by name multiple times. So when Janus invited me here to their Gosford facility, I knew I had to take them up on it. I'm here to see the trucks, see the conversion process, and talk with CEO Ben Hutt to find out whether battery swapping can live up to the hype that all of you have enthusiastically recommended in my comment section. So let's go in and find out.
Diesel truck rolls in at this end of the factory. We remove the engine, gearbox, fuel systems, cooling, all of the things that the diesel truck needs, the electric truck doesn't, and they all get sold for second-hand parts. And then on a day-by-day basis, this is roughly a 6-day process. The truck will roll down the line, and as it goes down, components are added to electrify the truck. So we add battery receptacles, as you can see here on the side, in place of the fuel tanks. We start adding wiring, so there's 5 wiring harnesses link up to this PDU on the back, and effectively along the way the new electric drivetrain and all of the mechanics to run power steering and all the other systems of the truck get put in, and that's effectively the Janus conversion kit is everything you see in here. The focus of this factory is not actually this line. The line is here really as a kind of dealer training and a center of excellence, really. So we bring our dealer partners in here, train them, educate them, and then give them all the instructions and everything they need to go away and do what they need to do. Typically, every 5 years, the truck has to have an engine rebuild or a gearbox. So we try and catch them at that point, either as a fleet is replenishing them. So in some cases, we're converting customer trucks. So as an example, this Cement Australia truck was a truck they've had in operation that they wanted to electrify. So we're converting it for them and then we give it back to them. In other cases, we are now buying trucks and converting them and then putting them out as rentals or as leases as well.
So in terms of like the weight of everything you take out and the weight of everything you put in, like what's the change?
At the moment, it's roughly the same. In 3 months' time, when we get our new batteries from Canada, and there'll be a slightly smaller version of this drivetrain, which will be another 400 kilos lighter, and the batteries are 500 kilos lighter, so we'll be almost a ton lighter than we are today.
And then what's the range of the batteries?
Yeah, so the range for a single trailer, so up to 70 tons, will be about 450 kilometers, fully loaded. For the road trains we've done these 3-car road trains with one of the mining haul operators. We're getting about 170 kilometers, towing 220 tons. The thing about trucking is it's not all about the big highway routes. 80% of the freight in this country with these big trucks does less than 280 kilometers a day. And most of it's out from base back to base, which is where the cement trucks work, or in and out of a port. So the trucks are all coming back through the same gates, so you can put a charge station on the port, so you don't need to worry about the highways.
If that's the case though, then why can't you just do regular charging, plug it in while you're loading, unloading? If you're going back to the same place, sounds like that should be easy. So why would you even need battery swapping?
The truck can keep moving. It doesn't need to sit still and change. I think down the track there will be an option to plug these trucks in overnight, but the current version of technology that you see here is very much the swappable battery is part of that.
What about battery cooling?
Batteries are air cooled, And they're air cooled in the charge stations as well, or air heated, because obviously in some colder markets you need to bring them up to temperature before you can charge them. Actually some patented technology we have in the batteries that's partly to do with the ceramics that sit between the cells, but also how the cooling is done. So they're all air cooled by systems that are on the truck and in the charge station.
And then what about regenerative braking?
It's all added back in through the drivetrain. So goes through the same systems.
Let's talk about materials for a second, because they matter more than people think. There's one in particular that's been showing up more and more across infrastructure projects. It's called fiberglass reinforced polymer, or FRP, from Bedford Reinforced Plastics, who are the sponsor of today's video. And if you're a frequent viewer of my channel, then you will have heard me talk about it before. It's strong, lightweight, and designed to handle harsh environments without rusting, corroding, or degrading over time. That's a big deal in places like wastewater treatment plants, utilities, and even architectural structures where durability is critical. It also helps reduce maintenance and extend the life of the overall system, which is exactly what engineers are trying to solve for. And it's made in the United States. You'll see it used in platforms, grading, and even pedestrian and light vehicle bridges. If you want to learn more, take a look at bedfordreinforced.com. Now back to trucks. Now let's go look at the components that go in the conversion.
This is effectively what we call an electric drivetrain. So it's a big electric motor coupled with a 16-speed automatic gearbox. This 16-speed gearbox will tow up to 220-ton road trains. And then on the top of this, we have all the systems that run all of the hydraulics on the truck, power steering, brakes, the other systems on the truck. Those two things together, you end up with this, which we call a kit. So this is what we call a conversion kit, which basically goes in the truck.
And how many Janus trucks are there in Australia?
It's 28, and there's now 4 overseas, 2 more on the way. I mean, if you come back here in 3 months' time, this will look completely different, because there'll be stations with these things. We'll be making sort of 2 or 3 of these a day now, and they'll mostly be getting shipped overseas.
Next, we watched a battery swap.
It's pretty easy to change the batteries. Gravity is our friend. They're quite heavy. Obviously, to be on a vehicle, they have to be crash resistant, tightly bound in, which they are. So we've got quite a lot of engineering tied up in making the plug. It's kind of complicated to engineer it, but really, really easy to change it. And I think the benefits of swapping are numerous. You know, the truck only sits still for 4 minutes, which is actually less time than it takes to fill up with diesel. So the truck drivers are all swapping their own batteries at the moment. And the slightly bigger version of that container has a forklift that lives in the container. So they can literally be dropped pretty much anywhere. There's a normal grid connection, like we don't need a special grid connection, and truck drivers can all drive a forklift. We've developed robotic charge and change stations for scale operations, where trucks can just drive in, little robotic arms come down, take the batteries and swap them over. We're not quite there yet, but as and when scale comes to life anywhere in the world, that's a product that we'll be able to deploy then.
What kind of grid connection does it need for powering the charging?
It's been designed to be not needing a special grid connection. What's it, 240, 300 amp feet? Great, there you go, not the engineer. So you can put them literally anywhere where there's a factory or a building. The batteries get to be charged slowly, which means they degrade much less rapidly. So our whole plan for the charging infrastructure is to put it on ring roads around major town centres and really have it as a distributed asset that serves a purpose for the grid, because it soaks up excess solar during the day. There are actually batteries that can be used by retailers and distribution network operators to sort of strengthen the grid. So they're a natural grid asset, but they're happy to be useful in trucks as well. In a 40-foot container, which is now the standard, there's room for 8 batteries. And that would service a fleet of up to 10 trucks, changing the batteries once a day each on a double shift.
A lot of people always want to know about, like, how can it combine with solar power? How can it combine with something like vehicle to grid? Yep. So, like, if you've got a warehouse and one of these stations, how much of your own energy are you going to be able to generate just from the solar panels on the roof?
Obviously depends how much solar you've got, but we have customers powering entire sites with these things, really using them as a battery to soak up the excess solar, because there's no feed-in tariff to be spoken of anymore. And so that ends up with a very, very low cost of energy going into the truck, which makes it even cheaper to run the electric truck.
What do you do about battery degradation? Because obviously all of the batteries are degrading at a slightly different rate. So maybe, one time a truck gets a battery at 100%, the next time it's 80%, it's going to reduce their range. How are you managing that and avoiding surprises for the truck drivers?
So all the trucks and the batteries and the charge stations all have software that ensures that the batteries are ready to go when they need to be ready to go, and equally that they're not overcharged and they're not stressed. So we've got very, very good warranty provisions on the batteries, so we think it'll be less than 20% degradation over the first 8 years, and we actually think they'll live probably 15 years. If the batteries, let's say, are 10 years old, they're not performing as well as they need to be, we'll just swap them out for new batteries, because the truck and the batteries are separate. So we can swap the chemistry in the batteries if we wanted to without it impacting the truck. And then these batteries all have a second life as stationary batteries in other utilizations. We've already got counterparties who are ready to buy batteries when we finish with them.
So if the Janus trucks are lighter, but they carry the exact same trailer with the exact same amount of space in it, I'm just really not understanding how that's possible. Like, what is the reason why the Janus trucks are able to stay underneath that limit, whereas overseas manufactured electric trucks are coming in heavier and causing all of these problems when it comes to local council regulations for load limits?
I think the principal reason why they're all a bit heavy is because they're all striving to have a range claim. They've got really heavy batteries in them. Trucks that we're competing with in different parts of around Australia, they're all over 7.5 tons from a stereo axle weight, so they've got more of a ton of mass in the front of the truck than we have. That then goes to local council for approvals, which is a complete mess for everyone. All of our trucks will be well under all national standards. We can obviously move the battery, influence the center of gravity. We can move the kit, as we call it, so the drivetrain and motor back in the truck to alleviate front axle mass.
What's the cost difference between having just regular electric trucks and chargers compared to having the battery swapping? And then you also obviously need to add the swap station. There's land that needs to be available for that. How do the economics stack up between the two different kinds of different trucks?
Yeah, it's much cheaper to convert a diesel truck to electric than it is to buy an electric truck. It's roughly a quarter of the cost. Increasingly now we're providing batteries and charging as a service, so people don't have to spend the money on that. They just get to use the batteries and use the energy in them as a service. And that, I think, is a key piece of making this accessible to the small fleet operator.
So how is this going to look in the future when there are a whole lot more electric trucks on the road? Presumably they're not all going to be Janus, but is there going to be interoperability? Like, are you going to be able to swap Janus batteries into non-Janus trucks?
Any type of Janus truck can use a Janus battery. So it might be a Volvo, it might be a Mack, it might be a Kenworth like this one. They all use the same batteries. So they are interoperable with different truck OEMs. They're just not interoperable today with other battery OEMs. But I think over time these things will all play out. So much of today's trucking is done with trucks leaving base and going back to base that the interoperability is not an issue for most fleets. What does become an issue is down the long corridors, where you might have trucks going up and down the Hume, let's say, is that they need to be able to use the infrastructure that's there. So whether that's battery swapping or plugging the trucks in, or maybe plugging these trucks in. I think over time there'll need to be a degree of interoperability between the charging infrastructure and the batteries. We're ready to participate in that and happy to collaborate with everyone.
All right, so now let's see what it's like to ride in one of these things.
So from a driver's perspective in here, the only difference is that screen there, which is just our battery monitoring, and it tells us what gear we're in.
Now let's compare that smooth ride to a diesel truck. It's so noisy to drive around for hours listening to this. Yeah, alright, this pretty much sucks compared to the electric version. Well, that was a very informative couple of hours that I've just spent at Janus. There were a lot of interesting things said, but two main ones stuck out to me. First, the difference between the electric and the diesel trucks that I drove in. I've actually driven in a few electric trucks by now, but never a diesel one until today, excluding like a tow truck. Diesel trucks are so loud and bumpy. What a terrible workplace for drivers who spend 8 hours plus per day in them. Then the second big thing that I was unaware of before the visit today was the extent of Janus's plans to scale. It is so fast. Janus currently has around 30 trucks on the road, and by the end of this year, they're planning to produce 50 kits a month, mostly for partners at other locations to install. So in some cases, that scale up is being driven by government mandate, which really helps with the economics for Janus and their scale up. But Janus maintain that it's not necessary, that the conversion and battery swapping already stands on its own without subsidy. One of the main advantages of Janus's approach to doing retrofits is how fast that means things can go, because it means we don't have to wait for these trucks to reach the end of their life before electrifying. We just need to wait 5 or so years for them to need engine rework. And another really big advantage in Australia especially is the lower weight of the retrofitted truck compared to the new electric trucks that are available in the market today. And that bypasses a lot of problems that other electric trucks are facing. The patchwork of inconsistent and in many cases nonsensical local council rules need to be addressed anyway. That is something that governments could so quickly and easily fix to speed the rollout of electric trucks across the country. I really hope that that's on the way soon because it's not that hard. But while we wait for that to happen, Janus customers aren't constrained by those issues. Big thank you to Janus for inviting me here today, and just want to note that they did pay my travel expenses, which weren't much. I just drove off in my EV, and they don't have control over the final video or anything. Thanks to you for watching, and a special thank you to my friends who are experts in electric trucks who contributed background research and suggested questions for this video. You know who you are. If you want to support this channel, then you can join as a Patreon or YouTube member. The links are in the description below. Thank you for watching, and I'll see you in the next video.